Hello everyone. First, let's look at the solution for the first question, and there are 5 parts. We have known that x and y have the joint density function, and first let's find a so that it's valid. And to make it valid, we should make the integral in it's equals 1. So we know that the integral for x is -1 to 1, and y is also -1 to 1. 1 plus x times y over a times delta x delta y equals 1. So the left hand side equals 4 over a. And to make it equals 1, we got a equals 4. And the second part, we have to show that if x and y are uncorrelated. So let's first find the marginal PDF of x and y. According to the definition, f sub x of x equals integral from -1 to 1 and a joint density function times delta y and equals 1/2. Similarly, we can know that f sub y of y also equals 1/2. So we can know x, random variety x and y, both of them are uniform distribution. So the expected value of x and y equals 0. According to this formula, we can calculate the covariance of x and y. It equals expected value of x times y minus expected value of x times expected value of y. Since these are 0, and it equals expected value of x times y, and it equals the integral of x, y times joint density function of x and y. So we can find the answer equals 0. So we can say x and y are uncorrelated. And the third part is to check if x and y are independent. To check this, we must check if the joint density function of x and y equals the product of the fx of x times f sub y of y. And we can easily know that the left hand side equals 1 plus xy over 4, and the right hand side equals 1/2 times 1/2 is 4 is a quarter. So obviously they are not equal. So x and y are not independent. And the fourth part, find the joint density function of x squared and y squared. So first, let's let z equals x squared and w equals y squared. We can calculate these two equations, and we found there are more than one valid solutions. Actually, there are 4 solution pair, and I listed them. So Jacobian equals delta 2 times square root of z 0, and 0 2 times square root of w, and equals 4 times square root of z times w. And similarly, we can find the Jacobian of x2 y2 equals -4 and square root of z times w, and the same. So we can find the joint density function, joint density fzw equals the summation of I equals 1, 2, 3, and 4, and 1 over the absolute value of Jacobian and times the joint density function of x and y, and for each xi, yi. And after calculation, we find the answer equals 1 over 4 times x times y, and x, y are both greater than or equal to 0 and less than 1. And the last part, we have to prove or disprove that x squared and y squared are independent. Let's say first we find the marginal density function from the consequence in the first part. So f sub z of z equals integral from 0 to 1 over 4 times square root of z times w times delta w. It equals 1 over 2 times square root of z. And similarly, the PDF of w equals 1 over 2 times square root of w. So we can check PDF of z times PDF of w equals 1 over 4 times square root of z times w, and it equals to the joint density function of z and w. So we can say that x squared and y squared, that's z and w, are independent.